Hello all and welcome back. So in this video, let us continue our discussion on linked list, and now let's try to delete a node at a given index. So let's get started. Now as of now we have seen how to delete at a head and tail. For deleting at a given index, let us first consider a linked list. So this time I'm going to draw it like this. Now of course we are a lot clear on how exactly linked list is joined. And I'm showing you these different approaches so that, let's say if you have an interview tomorrow face to face, you can just draw it like this instead of making those boxes. Of course, it will be a little quick, but initially it is very helpful when you are understanding that we don't draw it like this directly, so that you are able to understand on what exactly the pointers are going to change. If you still have an issue, though I believe it should not be there, if you still have, please make sure to draw it completely with boxes and both the values, the data and the next mentioned in that boxes. Okay. And this is finally done. Great. So this is my linked list, everyone. This is the head. Now, again, we have seen this many times. This is the zeroth node, first, second, third, fourth. Okay. Now, what do we have to do? Let us first write that. And the understanding of insert at a given index will again be very much helpful here, right? So, for example, let us assume that we have to insert, sorry, not insert this time, we have to delete, bad, yeah, we have to delete node at index 3. Okay. So finally, I have to make sure that I'm able to delete this node. Now, how will we move around it? Let us see. The very first understanding is that to delete this particular node, I should not be standing on this node, right? Like my temp variable, again, see, what we have to do is we have to make sure that we maintain a variable, let's say temp. That variable we will be moving so that it can reach somewhere. When we were inserting at a particular node, we used to stop one before that index, right? The reason is we have to make sure that we are able to change these indexes. Let's say if 35 is there, the whole game is of these pointers, these next, right? Here as well, if I have to delete this node 40, then what I believe should happen is that I should stop at index -1. The reason is that if I reach at 40, then there is no way I can change this overall next pointer, this pointer, right? So for that reason, we will again be stopping at index -1, exactly the same way we did in insert at an index. So please make sure that you see that video if you haven't. And once we are here, then to delete this, right? What exactly is needed? Let us pay attention to it. Okay, let us see the linked list and let us pay attention to it. So let us just visualize this once. Okay. Again, gonna show you this by using, one second, have you not called, my bad. So just give me a minute, everyone. Let us just call this take input better. We know that it's going to create a same list, right? So head is equals to take input better. And we are just saying println head. Great. Okay, so yeah, I think there we have a linked list, right? There we have a linked list. Now pay attention, everyone. This is the exact list which we have. Okay. If I have to, let's say, delete this node we have to delete. Then I will be making a temporary variable, starting it, and a count. So exactly same mindset which we did the insert. My aim now is to stop at this node. We have to stop here. Once I am on this temporary node, and if I have to delete this particular node, I think if I just make this connection, right? If I just skip my node and I'm able to make the rest connection, again, that is important because if I make this null, if I directly make this null, then we will lose 50 as well. And let's say anything after that, 50, 60, anything, right? So something which we don't want to do. So for that matter, what we have to do is we have to just join with this connection. This connection should be complete. Now, I hope you're able to visualize. Now, that's the reason I'm showing you this here. This is where this particular connection is happening, right? So we have to make sure that the node which is getting deleted, before deleting it, before we skip over it, we are able to preserve everything which it had, which was the rest left linked list, right? This node only knows that who was after this, who was after this particular 40 node. So to save that information, we will have to make sure that first, or rather just we make this connection, okay, not just directly make it none, because else we are going to lose all of our leftover nodes. Okay, so I will just repeat it once again, everyone. Pay attention what's going to happen. We will get on this 30 node. Our temp variable will be here. We know that temp dot next is something which we have to delete, right? This is the node we have to delete. But if I delete this node, first let us think, although we have done this already in the last two videos, yes, we have to delete this node. The way to delete, we can just delete its reference, right? Wherever I'm pointing to it. So if I delete this, yes, node will be deleted from memory because now no reference is there, right? But I have to delete just this node, okay, not the whole linked list after that. So I have to make sure that I join and preserve this connection. Now, which node is after 40, which is basically the node we are deleting? It's the 50 node, and the information is there in 40 only, right? So for that matter, we will have to first make sure that we make just this connection. So we are able to preserve the leftover list. Okay, everyone. So I hope it is a lot clear now after visualizing. It's the same as if we want to delete a children in between the example we saw. We have to make sure that we ask that children, hey, who was after you? So that we don't forget all of them who were after that particular child. Okay, great. So yeah, let us now go back and once I hope this is clear now how we have to delete it. Now let us try to code this once, everyone. Okay. So we are going to write def delete at index. I'm going to get the head and index this time, right? No data because we have to delete. Great. First, let us talk about the base case. What if you are asking me to delete head? Well, if you're asking me to delete head, if the index is 0, okay, I can ideally return you head dot next, right? I can do that. Just one thing I think we should check. Our head should not be null. If our head is none, then of course you cannot delete anything, right? So we should just return head as it is. Again, I will repeat what we have done here. Okay, so just let me try it if it is zooming in. No, it will be a lot. Should. So let me remove this. Yeah, cool. See everyone. I am first checking is the linked list empty. If it is empty, then I don't think we can delete anything, right? So for that matter, it is very important to do this. Okay, that's the first thing. Next, if my index is 0 and because I'm doing it iteratively, I can write it here as well. Print linked list is empty, right? So we should just also tell that linked list is empty, how you are asking me to delete anything. Great. Once this is done, I have to check if index is equals to 0. That is, are you asking me to delete the first node? If not, oh sorry, if yes, then we can return head dot next. Now this time this will not give me an error because I have already checked. Okay, sorry, it should be equals to none. My bad. Yeah, I have already checked and head is not none this time. So dot next will work, right? Great. If that's not the case, if both the cases are not there, then temp is equals to head, count equals 0. This is something which we have done already. While temp is not none and while temp is not none and count less than index minus 1, right? Again, this is something which we have done already. We saw that how this count, okay, how this count should be less than index minus 1. Great. We should just do two things. Temp is equals to temp dot next. Hey temp, move to the next one. Count increase by 1. Okay, so I will start from here, move here, move here. This will become 2 here. Let's say third node was there. So I will just come out of the loop this time. Great. If this is done, so once we get out of the loop, everyone, we have to just check, just like we did in the insert at an index, if our temp is none. If that's the case, then we should print out of bounds and just return our head. Okay. If that is not the case, then we know what we have to do. Temp dot next is going to be equal to temp, one second, yeah, temp dot next, right? And I can just return my head. So we have just jump over my middle loop. So this is where temp is. I'm saying temp dot next, please become equal to this next, right? If you want, you can break it like this as well. So let me break it for you. Node to be deleted is equals to temp dot next, and node after deleted node is equals to node to be deleted dot next, right? So I hope this now makes a lot of sense. We are on 3. Node to be deleted is 40, which is temp dot next, and node after deleted node is node to be deleted, which is 40 dot next, right? And now actually you can just maybe use this directly. So I hope this is now a lot clear. Okay. And yes, we can return the head. So let us try this out as well, everyone. I hope the whole overall idea is clear. Again, we are just checking few things. We should make sure that our linked list is not empty. Then we have to return it. And we have to also print that LL is empty, right? And the next part is if index is 0, then head dot next directly. Then we create a temp head and count 0. Traverse our linked list till we are able to reach to a node just before the node to be deleted, saving all this information and just returning the head. Okay, great. So let us call this everyone and let us try to delete in the same way at third index. Okay, cool. Let us just run this quickly. So 10, 20, 30, 40, 50 minus 1. See, 0, 1, 2, 3, 4. Right? So I have this 5 element linked list. I am able to delete the third index here. I'm talking about index. If you are asked this question in an interview, please make sure, or let's say on any website, please be clear that what exactly is being asked. For example, if position is there, then maybe it is one indexed, right? So you have to just change your logic. Either just make it -1, whatever position is given. So many times this position and index are where interviews or these websites play. So you have to be smart about that. Okay. Don't make the mistake. The whole logic is going to be the same. Great. So cool, everyone. Now let me just actually try this on one more thing. 10, 20, 30 minus 1. Okay. One second. I think we have to change this. Yeah. Head 3 should be fine. Okay. Great. So we are seeing the error. I will just actually rerun it so that you can catch it again. One second, everyone. See what exactly is going to happen. So when I'm running this, one second. Yeah. When I'm running this file, I'm saying 10, 20, 30 and -1. So linked list is having 3 nodes, 0, 1, 2 are the indexes. And I'm asking it to delete this 3, third index, fourth position, right? Which of course is out of bounds. But our code is failing. Okay. Our code is failing. So again, a good point to pause the video and think that why is that happening and can we able to solve it. Okay, great. So cooler. Then let us move forward and understand why this is happening, everyone. So let us go to Python tutor once, and I'm going to do it by explaining you visually so that we can see the working as well. Okay. Again, this question is going to be a lot helpful in many future questions which we are going to do. So please make sure that you understand each and everything. Okay. So I'm just making it 10, 20, 30 so that it is easier for us. Great. So let us visualize the execution. It is okay. It is giving us the error. So we have to go back before we are with the input, right? So let's say I'm just having the input as of now. This is where we are, head, right? Now I will try to delete at an index. So this delete at index gets called. Okay. I am at head, which is 3. Sorry, which is this 10. And index is 3. Now it is not none. So we are going to move forward. Index is not 0. Let me try to zoom in as well. Yeah. Index is not 0. So again, I'm going to move forward. That is fine. Temp, I'm making head, count 0. Now let us run this loop and pay a lot of attention on what exactly happens inside this loop. These small intricacies are the major places where you will be failing or passing your interviews. Okay, great. Now temp is equals to temp dot next. So I'm moving here. Count will become 1. Great. Now temp is equals to temp dot next again and count will become 2. At this point, this particular condition, count less than index minus 1. Index is 3, right? So it's going to be 2. Let me use white color. Yeah. It's going to be 2. And 2 less than 2, it's false, right? It is equal. So what does that mean? Our loop will exit here. And we will come to the next line. See, temp is still not none. And we reach this condition, right? But again, you are asking me to delete this node, which of course is not present, right? No node is present here. Now what is happening? Temp is not none. Yes, exactly. Node to be deleted will become temp dot next. Okay, so somehow you are asking me to delete none. That is fine. But the problem happens when you say that something is there after this none, right? That is where I have problem. I don't have anything, right? This none, it's not a node. And again, you are doing this mistake. None dot next, right? How can we handle that? Why is this happening? The reason for that is we missed a case. Okay, we missed a case. Along with temp is none, we should also check if temp dot next is none or not. Because if temp dot next is none, just like in this case, temp dot next is none, then that implies that we are at the tail. So if you remember, we have discussed this many times how temp dot next equals to none is a check for tail, right? So we are at the tail of our linked list and you are asking me to delete the next node. I hope you're able to understand why that is bad or why that is not possible. The tail is the last node. You are asking me to delete a node after that. So that's of course out of bounds only, right? So I hope this is clear a lot, everyone. Again, I will just repeat. You can see the same as well visually in front of you. Let me just move this pointer. Yeah. We are on this temp. Temp is not none. But you are asking me to delete the next node to the tail. We are at tail right now. So we will have to, along with temp none, we have to make sure to check if our tail is, if our temp is tail or if our temp dot next is none. The reason, if you are on the last node, how can you delete a node after that? So that is index out of bounds, just the very boundary condition. These along with 0, these are the condition which we have to pay focus on. Okay. So let us go back to our code and fix this, everyone. So along with this, if I just make and sorry, not and, or temp dot next is none. If any of this is the case, then we have made some mistake. So let us run this again now, everyone. 10, 20, 30, and minus 1. And see, your code is now working fine. It is showing that out of bounds. And we can see that it is out of bounds. 0, 1, 2. You are asking me to delete at index 3. Though I just have 2 overall, 2 as the maximum index and 3 elements, right? So again, everyone, please make sure that you are always checking your code against these boundary cases. Okay. In the middle, your logic is going to work fabulously well. We have seen the same here as well. The problem happens on these boundary cases where the head is there, where the tail is there, where we might encounter none. That is where you have to avoid these things. Okay. So cool, everyone. Now you have to do this question recursively, right? The same code you have to make sure that you are able to write recursively in the assignment which you will get after this. So the understanding is going to be the same and I think it will be a lot more easy now. Okay, everyone. So yeah, let us meet in the next video. One more thing, the complexity I think you can found it's O of n, big O of n. The reason is that we might have to, in worst case, go to the very last of my linked list. Complexity is big O of n when compared with an list or an array. When compared with a list on an array, if we have to delete the last element, if we have to delete the last element, right? 1 second. Yeah. Okay, so not able to do this. Wait. No worries. Yeah. So if we have to delete this last element, everyone, in linked list or array, what we do is this is our overall linked list. Sorry, this is our overall array. We can just in a way say that size is less than size is equal to size minus 1, so that's going to delete it. Okay, that's O one way. Otherwise we will of course have to make a copy. Okay, so depending on how we are actually handling our array, is it based on the size or capacity or just a proper full array? If it's a proper array, then you will have to again make sure that you copy all the elements into a new array. So that's the ON approach. If you are maintaining just the size, then you can just do size is equals to size minus 1, so that can be O of 1 as well.